Hello everyone. So here in this video, we are going to discuss in AIET 4 JEE class level solutions. Okay. So we are going to see some important questions and the questions which you face are very difficult. Okay. So let's start with the first. So question number 31 states that the barium chloride and sodium phosphate react according to the equation 3BaCl2 plus 2 Na3PO4 gives Na3PO4 twice plus 6 NaCl. Okay. If 0.5 mole of BaCl2 is mixed with 0.2 mole of Na3PO4, how many moles of Na3PO4 twice are formed? So you can see from the given reaction, 2 moles of sodium Na3PO4 phosphate gives 1 mole of barium phosphate. It is barium phosphate. Okay, means 2 moles is giving 1 mole. Just it is the half the mole of Na3PO4 is formed in as Ba3PO4 twice, right? So here they are asking if 0.2 mole of Na3PO4 is mixed. So first, what we have to do, we have to find out the limiting reagent which is present here in the reaction. So how to find out the limiting reagent from the given reactant? So the one which is present in very lesser amount is called as the limiting reagent. So Na3PO4 is present in as 2 moles and BaCl2 is present as 3 moles. So obviously it is clear that Na3PO4 is the limiting reagent. And the product depends only on the limiting reagent, right? So it depends only on Na3PO4. So 2 moles of Na3PO4 gives 1 mole of Ba3PO4 twice, and 0.2 moles of Na3PO4 gives how many mole of Ba3PO4 twice they are asking. It is just the half of it, right? That is 0.2 moles produce 0.1 mole of Ba3PO4 twice. Okay. So option D is the correct answer. Very easy. Okay, just find out the limiting reagent and try to get the answer. Moving on to the next question. 1 liter of 18 molar NaOH solution in water has been diluted to 100 liter. The molarity of the resulting solution is. 4 options are given and we are asked to find out the molarity. So they have said that initially we had 18 molar NaOH. So what is meant by 18 molar NaOH? 18 molar implies that 18 moles of NaOH is present in 1 liter of water. Okay. So on dilution, only the volume changes. So the number of moles remains constant over there. So the initial moles of NaOH is 18. So the final moles is also 18. So what is the final molarity? So the final molarity is, what is the formula to calculate the molarity? This number of moles of solute divided by volume of solution in liter, right? So the number of moles remains same. So it is 18. And the volume of solution you have to represent in terms of liter. Only the volume changes. That is, it is changing to 100. 1 liter is getting converted to 100. So the answer will be 0.18 molar. So option A is the correct answer for this. Okay. Then coming to question number 33. So here you can see on heating pure limestone dissociates as calcium carbonate is the limestone. It is getting dissociated into calcium oxide and carbon dioxide. If 200 grams is heated in an open container, compute the reduction in its weight and the atomic masses are given. So in terms of grams, Let's write in terms of grams. CaCO3 is getting converted to CaO plus CO2, right? So what is the molecular mass of CaCO3? So for calcium it is 40, and for carbon it is 12, and for oxygen it is 60. So you will get 80. I'm sorry, we are having 3 oxygen. So 16 into 3 we have to do. So what is 16 into 3? The 3 is 18 and 48, right? So we have to add 40, 12 and 48. So what you get? You get 100. So 100 gram of CaCO3 produces how many grams of carbon dioxide? To calculate the molecular mass of carbon dioxide, for each carbon it is 12, and we are having 2 oxygen. So 16 into 2 is 32, and the molar mass of carbon dioxide is 44. So 100 gram of CaCO3 produces 44 gram of CO2. If 200 gram of CaCO3 is heated, it obviously produces 44 into 2 gram of carbon dioxide, right? That is, it forms 88 gram of carbon dioxide. So option B is the correct answer. Got it? Now moving on to the next question. Question number 34. 30 gram of a substance of molar weight 15 AMU when dissolved in 2170 gram water yields a solution of density 1.1 gram per milliliter. The molarity of the solution. So what is molarity? Molarity is number of moles divided by volume of the solution in liter. Okay. So do we have the volume here? Do we have the volume here? No, we don't have the volume. We just have the density. So we know that density is equal to mass by volume. And from this you can find out the volume from mass by density. So what is the given mass? The given mass is 30 gram. 30 gram is the mass of the substance. And the density is 1.1. So 30 divided by 1.1 gives you the volume. But we have to take the total mass of the system, right? So 30 gram is the mass of the substance. And it is dissolved in 2170 gram of water. So what is the total mass? 30 plus 2170 divided by 1.1, which is equal to 2200 divided by 1.1, which is equal to 2000 milliliter, we can say, and it is equal to 2 liter. So the volume is 2 liter, and we got the volume. And now we have to find out the number of moles. The number of moles can be calculated from mass by molar mass formula, right? Number of moles can be calculated using mass by molar. So the mass of the substance, it is the number of moles of the solute. So solute is the substance, and its mass is 30 divided by the molar mass is also given. This molecular weight is given here as 15 AM. So 30 divided by 15 gives 2 moles, right? Now substitute in this equation. So molarity is equal to the number of moles of the solute, that is 2, divided by volume of the solution in liter, that is 2 liter. This is 2 moles, and you get 1 molar. So the molarity of the solution is 1 molar, in which option D is the correct answer. Okay. The quantum number of 4 electrons are given below. Choose the one that has the second lowest energy. So according to above principle, the electrons are arranged in the increasing order of energy levels. Okay. So from the given options, we'll try to find out the energy level. So the n value is given as 4 in option A. So it is 4 and L is 1. For a given value of n, if L is equal to 0, then yes, it is S orbital. And if L is equal to 1, it is p orbital. If L is equal to 2, it is d orbital. And if L is equal to 3, it is f orbital. And here n value is 4 and L is equal to 1. So it is 4p. And here n is 4 and L is 0. So it is 4s. So this is 3d. And in option D, we are having 3s. Now try to arrange the energy levels. It is written like this. No, 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, and it goes on. So 4p is at the higher energy level part, then comes 3d, and the remaining energy levels are coming. So in option A, we are having 4p, and option B, we are having 4s. So this is the first most higher energy part, and this is the second lowest, second energy level, which is the lowest to 4p. And then come, and this is 3d, and here we are having 3s. So you have to choose the one that has the second lowest. So sorry, this is the first lowest, and this 4s is the second lowest. So option B is the correct answer. Okay. So 4p is the highest, the first lowest is 3d, and the second lowest is 4s. So option B is the answer. Now coming to question number 36. The energy of a photon having the same wavelength as the de Broglie wavelength of a 100-gram tennis ball moving at 100 meters per second. So we are asked to find out the energy of the photon. And the de Broglie wavelength is given. So the de Broglie wavelength of the ball is written as lambda ball, which is equal to lambda is equal to h by mv, right? H is the Planck's constant and mass of the ball to h mv, velocity of the ball. Photon has the same wavelength as that of the ball. So what does this represent? So lambda of the photon is equal to the wavelength lambda of the ball. So then energy of the photon is also equal to the energy of the ball, right? We can relate this. Energy of the photon is equal to, we know that E is equal to hc by lambda. So it is hc by lambda of the photon, which is equal to hc divided by lambda of the photon is equal to lambda of the ball, which is nothing but h by mass of the ball into velocity of the ball. So what happens? H gets cancelled. mv goes in the numerator. So m, c, and b, the ball. So it is equal to mass is 0.1 kg. Mass is 0.1 kg. And the velocity is 3 into 10 to the power 8 meter per second. And the velocity is given as 10 meter per second. So on calculating, you will get 3 into 10 to the power 8 joule. Okay, which is the energy of the photon. So option C is the correct answer for this question. Got it? So it is given in terms of gram. Mass is given in terms of gram. You have to convert it into kilogram. So 100 gram is equal to 0.1 kilo. Just on substitution, we'll get option C as the answer. Okay. Then coming to question number 39. If the ionization energy of sodium is 5.48 electron volt, then the ionization energy of potassium will be. So sodium and potassium belongs to the same group. That is after sodium, that is lithium, sodium, potassium, rubidium, cesium, right? All these are group 1 elements. So ionization energy on moving down the group decreases because the size increases. So if the ionization energy value for sodium is 5.48 electron volt, then for potassium, it should be less than 5.48, right? So see to the options. It is given same as that of Na, it cannot be the answer. And in option C, 5.68, which is higher to 5.48 cannot be the answer, and 10 point is also not the answer since it is the higher value. So potassium should have lower value than sodium, which is 4.34 electron volt. And option B is the correct answer for this question. Okay. Then let's move on to question number 40. Which of the following statement is incorrect? So all the first and the second ionization, third ionization potential of magnesium, aluminium, sodium is related here. So let's write the elements. First, we'll go for with options. So coming to option A, the first ionization potential of aluminium is less than that the first ionization potential of magnesium. So magnesium has atomic number 12 and aluminium is having atomic number 30. So the first ionization energy of magnesium, the outermost electron be here, it is the NS2 and here NS2 and NP1, right? So the first ionization energy will be low for, first ionization energy will be less for aluminium. Ionization energy 1 will be less for aluminium. Okay, now after removing the electron, this magnesium attains NS1 and aluminium attains NS2, NP0. Now here in this case, the energy required to remove the aluminium is more. So second ionization energy is more for aluminium. So what does the first option says? The first ionization potential of aluminium is less than the first ionization potential of magnesium. That is the correct statement. Now come to option B. It talks about the second ionization potential of magnesium and sodium. So let's take the sodium and magnesium. Sodium is having NS1 configuration, magnesium is having NS2 configuration. Since magnesium is having fully filled configuration, magnesium requires the higher energy for the removal of electron. That is, the first ionization energy of magnesium is more. Then after the removal of that electron, NS0 and NS1 is the configuration. Now we can easily remove the electron from the magnesium since it has one electron, and for the removal of electron from sodium, we have to go to the inner shell, right? Means energy required to remove the electron from the inner shell is more for sodium. So the second ionization energy potential for magnesium is less than the second ionization potential of sodium, but it is given magnesium is greater than second ionization potential. So that is the incorrect statement, which is the correct answer for this question. Okay. And for sodium and magnesium, you can see in option C, it will be correct. And the third ionization potential of magnesium is also greater than that of aluminium. Okay. So option B is the incorrect statement. Okay. Then moving on to the next question. Question number 42. The state of hybridization of the central atom and the number of lone pairs over the central atom in POCl3R. So to solve this question, we need to draw the structure first. So it is P double bond O, Cl, Cl and Cl. So how to find out the hybridization of the central atom, that is phosphorus? We have to find out the steric number, right? Steric number is equal to number of sigma bonds plus the number of lone pairs. So how many sigma bond we have around this phosphorus? So 1, 2, 3 and 4, right? The other one is pi bond. So the total number of sigma bond is 4. And we don't have lone pair on phosphorus. So it is 0. So the final answer is 4. If 4 is the steric number, then the hybridization is sp3, right? So the hybridization of the central phosphorus is sp3 and the phosphorus doesn't contain lone pair in it, which is 0. So option C is the correct answer for this question. Okay. Then moving on to question number 43. In which of the following molecules or ions all the bonds are not identical? We have to draw the structure again. So option A is like this. It is HCF4, which is square planar in structure. And here we are having 4 bond pair or 4 sigma bond. If it is 4 sigma, then the hybridization is sp3 and all the HCF bonds are equal. And in case of BF4 minus, in BF4 minus also we are having 4 sigma bond and the hybridization of boron is sp3. All the 4 BF bonds are equal. In case of C2H4, that is C double bond C, H, H and H, H. Here you can see the carbon is doubly bonded. So the hybridization of this carbon is sp2. And it is having trigonal planar geometry. But we have 2 CH bond and 1 CC bond. So the CC bond, that is C double bond C bond and C single bond H bond cannot be same. They are not identical. So all the bonds are not identical in case of C2H4. So option C is the answer. And we can try with SiF4 also. It is tetrahedral in structure. Since the valency of silicon is 4, it forms 4 bonds and all the 4 SiF bonds are equal. So option C, C2H4 is the correct answer for this question. Now coming to question number 44. The types of hybrid orbitals of nitrogen in NO2 plus, NO3 minus, NH4 plus respectively are. Just try to find out the hybridization of the nitrogen. Let me draw the structure. It is NO2 plus. It is NO2 plus. So how many sigma bonds we have? We have 2 sigma and 2 pi bond. Then the steric number will be equal to 2 since no lone pair is present on nitrogen. So the hybridization is sp. Then come to NO3 minus. Nitrogen valence electron is 5 and it has the gain on electron. So it is N double bond O, single bond O, single bond O. Okay. So how many sigma bonds we have? NO3 minus. So one sigma and another one is pi. This is the sigma bond. This is also sigma bond. So 3 sigma bond we are having. So the steric number is equal to 3. If it is 3, then the hybridization is sp2. Okay. Then coming to NH4 plus. NH4 plus is tetrahedral in geometry, means 4 sigma bonds we are having. So the steric number is 4. So we do have 4 sigma. Steric number is 4. So the hybridization is sp3. So sp, sp2 and sp3. Option B is the correct answer for this question. Okay. Then coming to the next question. Which of the following are non-polar molecules? Which of the following are non-polar molecules? Just draw the structure again. First, let me draw the structure of NCl3. This is the structure of NCl3, where nitrogen has one lone pair. And here chlorine and nitrogen both are having the same electronegativity values. There will be no polarity of bonds. But the lone pair of electrons will pull the electrons towards itself and the bond gets polarized. Molecule gets polarized. So this is a polar molecule. And coming to SO3, the structure is S double bond O, double bond O, double bond. So you can see the structure is symmetrical. And all the symmetrical structures are having zero dipole moment, means they are non-polar. They are non-polar. In all the 3 sides, there is equal pulling of electrons. So the bonds doesn't get polarized. Okay. And coming to PCl5. PCl5 structure is trigonal, bipyramidal, and here also from all the 5 sides, the chlorine pulls the electron equally from the phosphorus. So the bonds doesn't get polarized, same non-polar, and also the structure is symmetrical. So compound 2 and compound 3, that is SO3 and PCl5, they are non-polar molecules. So 2 and 3 is the answer. Okay. So these are the 3 structures. Now the question number 48 states that the delta HF naught of CO2, CO, H2O are given. The standard enthalpy change for the given reaction is. So what is the standard enthalpy change for the reaction? That is, they are asking us to find out standard enthalpy change. Standard enthalpy change for the reaction. Delta HR naught we have to find out. It is equal to the summation of the standard enthalpy change of formation for the products minus the summation of standard enthalpy change in formation for reactants. For the reactants. So who are the products? CO and H2O are the products. So what is the delta HF naught value for CO and H2O? It is minus 110.5 minus 241.8 minus, and for the reactant you see carbon dioxide is minus 393.5 and H2, the standard, the delta HF naught for H2 is 0 since hydrogen is the standard state for H2. So for all the standard elements which are present in the standard state, the delta HF naught is equal to 0. So it is equal to 0. So just calculate this. So the answer would be minus 110.5 minus 241 is equal to, just substitute this, minus 110.5 and minus 241.8. 8, it is 13 and here it is 2, 5, 3 minus 352. Minus 352.3 and minus into minus plus is 393.5. So on solving this, you will get 41.2 plus 41.2 kilojoule per mole. So this is the standard enthalpy change for the given reaction. So option 1 is the correct answer. Okay. Now coming to question number 49. A gas expands adiabatically from 1 liter to 13 liter against a constant external pressure of 0.5 atm. The delta U of the gases. So how to find out the delta U? From first law of thermodynamics, delta U is equal to Q plus W. Okay. Since the given system is adiabatic, for adiabatic system Q is equal to 0. Right, so Q goes to 0 and delta U is equal to W. Now we have to calculate the W. How to find out the work done? It is equal to minus P delta V, which is equal to minus P external. This is P external pressure, and it is V2 minus V1. So what is the external pressure given here? It is minus 0.75. Final volume is 13 and the initial volume is 1. So 13 minus 1 is 12 and 0.75 into 12 gives you minus 9 liter atmosphere. Okay. So option D is the correct answer. So let's move on to question number 51. The IUPAC name of the compound. So it is CH2 double bond CH, CH, and to the CH2, CH3 groups are attached. So this is the given compound. And we have to start numbering from the alkene carbon. Double bonded carbon should get the first priority. So it is 1, 2, 3, 4. And in the third carbon, we are having a methyl group. So it is 3-methyl but 1-ene. It is 3-methyl. 4 carbon is there in the parent chain. So it is but. Between 1 and 2, we are having a double bond. So it is but 1-ene. Or you can write this as 3-methyl 1-butene. Both are correct. Okay. So 3-methyl 1-butene is given in option B, which is the correct answer for this question. Okay. Then let's move on to question number 53. So 8.21 decimeter cube of NS3 at 500 Kelvin at 1 atm expands adiabatically up to 0.5 atm against a constant external pressure of 0.5 atm. And assume that NH3 behaves as an ideal gas and vibrational degrees of freedom are inactive. R values are given and the value of delta U, modulus of delta U divided by 15 in calories. So what we are supposed to do? We are supposed to find out the delta U. So what is the formula to calculate the delta U? Delta U is NCV delta T. This is the one more relation which we have to find out the delta U. So here we need to find out the number of moles and we have to enter the CV value and the change in temperature. Okay. So to find out the number of moles is equal to, from PV is equal to nRT relation, N is equal to PV by RT. Okay. So what is the pressure given here? 1 atmospheric pressure is the initial pressure. So pressure is 1. And what is the volume? Volume is 8.21 decimeter cube. So it is 8.21. And what is the R value given here? 0.0821. And the temperature is given as 500 Kelvin. So on solving this, you will get 0.2 as the value for number of. So we got the number of. And also in the question, they have given the process is adiabatic. For adiabatic process, Q is equal to 0. So if Q is equal to 0, then from the first law of thermodynamics, we get delta U is equal to W. We get delta U is equal to W. That is delta U is equal to W. So what is delta U? It is NCV delta T, right? So what is NCV? It is NCV. Let me write this. NCV delta T, which is equal to, and the work done is minus P external delta V. And the N value is 0.2 and the CV is 3R. CV value is 3R for NH3. Since NH3 is the polyatomic gas, the CV value is 6/2R, so it will be 3R. And the change in temperature is T2 minus T1. T1 is 500 and T2 we have to find out, which is equal to minus external pressure is 0.5 atmospheric pressure. So it is 0.5 into this volume. So from PV is equal to nRT, N is constant, N is there and R is there. So what is P? P is equal to T by P, right? So instead of V2 minus V1, we can write T2 by P2, T2 by P2, take R out. So it is T2 by P2 minus T1 by P1. Okay. So N is there, N is there, N is there, number of moles, and here also we are having N, no? So N gets cancelled and we are taking this R out. So remaining is T2, T and P, which are the variables, and it is written like this. Okay. Now what we have to do? We have to find out, we have to take this term here. So it is equal to minus 0.5 R T2 by final pressure is 0.5 minus initial temperature is 500 divided by 1. This is what we are getting. Okay. And now from this we have to find out RR gets cancelled. RR gets cancelled. So 3T2 minus 500 is equal to minus T2 plus 250. This is what you will get on taking the LCM. So 3T2 plus T2 is 4T2 and 3 into minus 500 is minus 1150. You take this minus 1150 to the other side, it becomes plus 1250. So it is plus 250 gives 1750. You get 1750. And from this, the T2 value is equal to 437.5. Now substitute this T2 value here in this equation to get delta U. Delta U is equal to 0.2 into CV value is 3R and final temperature is 437.5, initial temperature is 500. Okay, on solving this, you will get minus 75 calories as delta U. And we have to find out, what we have to find out? We have to find out the modulus of delta U by 50. So taking modulus for minus 75, minus becomes plus on taking modulus, right? So it is 75 divided by 50, which is equal to 5. So the value for the given question, the value of delta U by 15 is equal to 5. So 5 is the answer for this question. Okay. So then let's go for the next question. Question number C5. So a flask containing air at 107 degrees Celsius and 722 mm of mercury is cooled to 100 Kelvin and 760 mm of mercury. If density in the initial condition is 1 gram per centimeter cube, then what is the final density? Okay, so we have to take the given values first. So what is the initial pressure? Initial pressure is 722 mm of mercury. And what is the final pressure? It is equal to 760 mm of mercury. And what is the initial temperature? It is 107 degrees Celsius. Convert this to Kelvin so that you can substitute directly. So add 273. The final value will be 380 Kelvin. And the final temperature is given here in terms of Kelvin only. So it is 100 Kelvin. And the initial density is 1 gram per centimeter cube. we are asked to find out the final density of the system. Okay, so we know that Di initial density, initial temperature into R by P is equal to final density into final temperature to R by the final pressure. So this is the relation we have. You know that molar mass and density are directly related to each other, right? So M1 is equal to M2. So that's from that we are getting this. So from this we have to find out the final density here. So just substitute all the values. So here you are having initial density, which is 1, and the initial temperature will be 380, and the R value, R gets cancelled on both the sides. And taking this PF to the other side, the final pressure is 760 divided by initial pressure is 722. Take that PF to the other side, to the denominator. So it is 100. So on solving this, we get the final density as 4 gram per centimeter cube. We get 4 gram per centimeter cube. Okay. So this is the answer for this question. Now coming to the next question. Question number 57. In an atom, the total number of electrons having the quantum numbers n is equal to 4, ml equal to 1, and m is equal to minus half s. So, for n is equal to 4, if n is equal to 4, the possible L values are 0 to n minus 1. 0 to n minus 1, which is 0 to 4 minus 1, that is 3. That is 0, 1, 2, and 3. And the possible m values or ml values will be minus L to plus L. This is the relation. If L is equal to 0, and if L is equal to 1, if L is equal to 2, if L is equal to 3. So minus L to plus L is 0. ML value is 0. And minus 1, 0, and plus 1 are the ML value for L is equal to 1. Here minus 2, minus 1, 0, plus 1, plus 2. And here minus 3, minus 2, minus 1, 0, plus 1, plus 2, and plus 3. So these are the ML values for the given L values. Okay. Now what we have to find out? The spin should be minus half. And the ML value should be 1. Now using this, you have to calculate the total number of electrons having this quantum. So just take the ML value 1 alone. That is 1, 2, 3, 4, 5, and 6. Since it is modulus of L, we can take both the orbitals. So totally we are having 6 orbitals. We are having 6 orbitals. So each orbital 1, 2, 3, 4, 5, 6. So each orbital contains 2 electrons. Each orbital contains 2 electrons, right? So, but we have to take out the electron which has only minus half spin. So in both the electron, one is plus half, the other one is minus half. So it is 1, 2, 3, 4, 5, 6. So how many total electrons we are having? Those have minus half spin have totally 6 electrons. Have totally 6 electrons for the given quantum number n is equal to 0, ml, modulus of ml is equal to 1, and s is equal to minus 1. Okay, so the answer is 6 electrons. Have totally 6 electrons. Got it? Now let's go for the next question. The minimum number of moles of O2 required for complete combustion of 1 mole of propane and 2 moles of butane. So what is the general reaction for combustion? It is Cn H2n plus 2 plus 3n plus 1 by 2 moles of oxygen gives n moles of carbon dioxide plus n plus 1 moles of water. So this is the general reaction for combustion, right? Now we are doing this with propane and butane. In case of propane, the formula is C3 and H8. And what is the n value for propane? The n value for propane is 3. So it is 3 into 3, 9. 9 plus 1 is 10. 10 by 2 is 5. So propane, 1 mole of propane reacts with 5 moles of oxygen to give 3 moles, that is n mole of carbon dioxide, and n plus 1, that is 3 plus 1, 4 moles of water. Okay. Now coming to butane. So what is formula for butane? It is C4H10, right? N value is 4 for butane. So for 1 mole of butane, let's calculate first. N value is put the n value as 4 and 3 fours are 12. 12 plus 1 is 13. 13 by 2 is 6.5 moles. 6.5 moles of oxygen gives 4 moles of carbon dioxide. 4 plus 1, 5 moles of water. This is for 1 mole of butane. 1 mole of butane reacts with 6.5 moles of oxygen. And for 2 moles of butane, what we have to do? It is 6.5 into 2, right? What is 6.5 into 2? It is equal to 13 moles of oxygen. So 2 moles of butane reacts with 13 moles of oxygen and 1 mole of propane reacts with 5 moles of oxygen. So now we have to add the total number of moles. So it is 5 plus 13, which is equal to 18. So 18 moles of oxygen is required for complete combustion of 1 mole of propane and 2 moles of butane. So the answer is 18. Okay. Now coming to the last question for this session. Boron has 2 stable isotopes, that is boron 10 and 11. The atomic mass that should appear for boron in the periodic table is. So what we have to do? So the atomic mass is nothing but the average atomic mass represented there in the periodic table which we are using. Now we have to calculate the average atomic mass. How to calculate the average atomic mass for the given isotopes? It is equal to the mass of the first isotope into the percentage of that particular isotope plus the mass of the second compound into the composition divided by 100. So 10 into 19 is 190 and 81 into 11, how much you get? So it is 891 divided by 100 and 891 plus 190. So what you get? It is 1081 divided by 100, which is nothing but, so the average atomic mass you will get here will be 11. Okay, so the average atomic mass is 11 and that is the atomic mass which is showed there in the periodic table. Okay, so that's all for this AIET course solution. I hope this video and the solutions which I have discussed here in the video, they are clear to you all. So thank you so much. Thank you.